Your company generates large volumes of transactional data daily. The data is accessed frequently for the first 30 days, but is rarely accessed afterward. You need to archive this data in a cost-effective manner while retaining access. Options: A. Store the data in S3 Standard and configure lifecycle policies to move it to S3 Glacier after 30 days. B. Store the data in S3 Intelligent Tiering. C. Store the data in S3 Standard IA and then move it to S3 Glacier Deep Archive after 30 days. D. Store the data directly in S3 Glacier Deep Archive. Correct answer: A. Store the data in S3 Standard and configure lifecycle policies to move it to S3 Glacier after 30 days. Explanation: Storing data in S3 Standard ensures fast access during the first 30 days, and lifecycle policies automate moving data to S3 Glacier for cost-effective long-term storage. Why not other options? Option B. Intelligent tiering is more expensive for data with predictable access patterns. Option C. S3 Standard IA is less cost-effective compared to S3 Glacier for long-term storage. Option D. S3 Glacier Deep Archive is not suitable for data frequently accessed in the first 30 days. You are hosting a stateful web application on EC2. The application stores session data in memory. You need to scale the application horizontally while maintaining session consistency across instances. Options: A. Use an application load balancer, ALB, with sticky sessions. B. Use an elastic load balancer with auto-scaling. C. Use DynamoDB to store session data and distribute traffic with an ALB. D. Use Amazon ElastiCache for Redis to store session data. Correct answer: D. Use Amazon ElastiCache for Redis to store session data. Explanation: ElastiCache for Redis provides low-latency session storage, enabling horizontal scaling while maintaining session consistency. Why not other options? Option A. Sticky sessions reduce scalability and may create uneven traffic distribution. Option B. Auto-scaling without external session storage leads to inconsistent sessions. Option C. DynamoDB is slower than Redis for session storage and not ideal for low-latency applications. Your company requires a relational database that is highly available across multiple AWS regions. The database must synchronize data between regions and automatically failover during outages. Options: A. Use Amazon RDS with multi-AZ deployment. B. Use Amazon Aurora Global Database. C. Use Amazon DynamoDB Global Tables. D. Use an EC2 instance with MySQL and configure replication across regions. Correct answer: B. Use Amazon Aurora Global Database. Explanation: Aurora Global Database replicates data across regions with low latency, providing high availability and disaster recovery. Why not other options? Option A. Multi-AZ deployment ensures high availability within a single region, not across regions. Option C. DynamoDB is NoSQL and not suitable for relational database requirements. Option D. Managing MySQL replication on EC2 adds complexity and lacks automated failover. You are managing a web application that serves users globally. Some users report high latency. You need to improve performance for all users while minimizing costs. Options: A. Use Amazon CloudFront with an S3 bucket as the origin. B. Use an application load balancer with auto-scaling. C. Use AWS Global Accelerator. D. Deploy application servers in multiple regions. Correct answer: A. Use Amazon CloudFront with an S3 bucket as the origin. Explanation: CloudFront caches content at edge locations, reducing latency for users worldwide. Why not other options? Option B. ALB only balances traffic within a region and doesn't cache content. Option C. Global Accelerator improves performance for dynamic applications but doesn't cache static content. Option D. Deploying servers globally increases operational complexity and costs. Your company requires a disaster recovery solution for an on-premises critical application. The solution must minimize downtime and data loss while being cost-effective. Options: A. Use AWS Elastic Disaster Recovery with a warm standby strategy. B. Use AWS Backup with S3 Glacier Deep Archive for data storage. C. Use AWS Storage Gateway with a tape backup solution. D. Use a multi-region active-active setup in AWS. Correct answer, A. Use AWS Elastic Disaster Recovery with a warm standby strategy. Explanation: Elastic Disaster Recovery ensures minimal downtime with a warm standby, replicating the environment in AWS for quick failover. Why not other options? Option B. S3 Glacier Deep Archive is cost-effective but has high recovery times, unsuitable for disaster recovery. Option C. Tape backup is slow and not ideal for critical applications requiring quick recovery. Option D. Multi-region active-active is highly available but significantly more expensive. You need to secure access to S3 buckets containing sensitive data. Access must be restricted to users from specific IP addresses. Options: A. Use bucket policies with IP condition keys. B. Use AWS WAF to filter IP addresses. C. Use IAM policies to allow access based on IP conditions. D. Use VPC endpoints with a security group. Correct answer: A. Use bucket policies with IP condition keys. Explanation: Bucket policies with IP condition keys restrict access at the bucket level, ensuring precise control. Why not other options? Option B. AWS WAF filters web traffic but doesn't restrict access to S3 buckets. Option C. IAM policies don't allow granular control at the IP address level for S3 access. Option D. VPC endpoints restrict access to resources within a VPC, not specific IPs. You need to build an event-driven workflow to process uploaded images. The workflow involves triggering Lambda functions to resize and watermark the images. Options: A. Use S3 event notifications to trigger AWS Lambda functions. B. Use DynamoDB streams to trigger Lambda for processing. C. Use Amazon MQ to handle the event workflow. D. Use step functions to manage the event workflow. Correct answer: A. Use S3 event notifications to trigger AWS Lambda functions. Explanation: S3 event notifications trigger Lambda functions directly upon file uploads, ideal for event-driven workflows. Why not other options? Option B. DynamoDB streams are for change data capture, not file uploads. Option C. Amazon MQ is for message brokering, adding unnecessary complexity. Option D. Step functions are suitable for complex workflows, but unnecessary here. Your company wants to migrate a monolithic on-premises application to AWS. The application has tightly coupled components and depends on local storage. The migration plan should minimize changes to the application architecture. Options: A. Use EC2 instances and attach Amazon EBS volumes for storage. B. Use Amazon ECS with Fargate and S3 for storage. C. Use AWS Lambda to host the application and DynamoDB for storage. D. Use AWS Elastic Beanstalk with S3 for storage. Correct answer: A. Use EC2 instances and attach Amazon EBS volumes for storage. Explanation: EC2 with EBS is the best fit for lift and shift migrations of monolithic applications with minimal architectural changes. Why not other options? Option B. ECS and Fargate require containerization, which may involve significant changes to the application. Option C. Lambda is unsuitable for monolithic applications because of its stateless nature and execution duration limits. Option D. Elastic Beanstalk requires decoupling the application components to leverage its platform effectively. Your company processes terabytes of data daily for analytics. Currently, the data is stored in S3, and you are using Amazon Redshift for analysis. You need to reduce costs while maintaining performance. Options: A. Use Amazon Athena to query the data directly from S3. B. Use Amazon EMR to process the data and store it in DynamoDB. C. Migrate the data to RDS and run analytics queries. D. Use Amazon Redshift Spectrum to query data directly from S3. Correct answer: D. Use Amazon Redshift Spectrum to query data directly from S3. Explanation: Redshift Spectrum allows you to query S3 data without moving it to Redshift, reducing storage costs and maintaining analytics performance. Why not other options? Option A. Athena is cost-effective but not suitable for large-scale analytics requiring advanced queries or joins. Option B. EMR with DynamoDB is expensive and less efficient for analytics workloads. Option C. RDS is not optimized for large-scale analytics and incurs higher query costs. You are designing a solution for real-time data ingestion from IoT devices. The solution must handle high throughput and store data for analytics. Options: A. Use Kinesis data streams for ingestion and Kinesis data firehose for storage. B. Use SQS for ingestion and RDS for storage. C. Use DynamoDB streams for ingestion and S3 for storage. D. Use Kafka on Amazon MSK for ingestion and store the data in DynamoDB. Correct answer: A. Use Kinesis data streams for ingestion and Kinesis data firehose for storage. Explanation: Kinesis data streams efficiently handles real-time ingestion, while Kinesis data firehose delivers the data to analytics storage like S3 or Redshift. Why not other options? Option B. SQS is not designed for real-time ingestion of high-throughput data streams. Option C. DynamoDB streams captures database changes, not real-time data ingestion. Option D. MSK is more complex to manage and incurs higher operational overhead.